You mentioned the deep fractures from your initial
Yeah.
roughing. What do you recommend for an initial grit?
What I recommend is not using a roughing lap like 100 or 220. If you need to get that much material off, use a saw. You can get like a 220 grit, 100 concentration, bronze rim slitting saw, as narrow as you can. An opal saw, 8 thousandths or so. Because it works beautiful on the fastening machine. When you use it in a trailing direction, just pull it slowly forward, and this little piece falls off, and this piece might be big enough to cut something out of a lot of times. You can cut most of your first row of facets that way, and establish the girdle that way, and have these little pieces. And and that's a lot of dust that you didn't have to make, and that's a lot of wear you didn't have to put on an expensive lap. I mean, I bought a 100-220 lap for a cabbing wheel. Okay, so I mean, I use that as a quarrying tool. But most of the stuff, you see, when we talk about fastening, we're talking generally about a crystal lattice. Now, there's things you can do to petrified wood and jade, things like that, that won't do this propagating damage as you would with a defined lattice. One is an amorphous material. And we're talking about a field where you can take the crystal and put a little saw slit in it, take a razor blade and a hammer, and have no kerf losses. You can cleave them. So, we're talking about a lot of materials that have defined cleavages. I mean, Bodamine, for example. What was the last one that just came out? So one of the feldspars that somebody, Matt Dunkel, was selling. I got one of those, but that's one where you didn't need a trim saw. Boing.
So would you start with a 360?
Yeah, I think about as coarse as I have in my shop is 360, is a 360 lap. And I use that for roughing, 600 lap for doing the actual cutting, and then 3K on cast tin for the pre-polish. And you'll find that with a proper balance of lubricant and diamond, that you can actually cut facets on a 3K, on a 3000 grit diamond. The smaller facets, table stars and stuff like that. I mean, table stars and stuff like that. So.
The smaller the stone, the finer the lap.
I'm sorry?
The smaller the stone, the finer the lap to start with.
Yeah, that's a good one too. I mean, obviously you get, the closer size the grit comes to being, to the size of what the work is, the closer you are smashing two rocks together.
You get down those little stones you don't need for a couple of laps.
Yeah, that's why I like Portuguese cuts.
You don't make as many mistakes.
You finish those up on the 50K, Lots of facets, but tiny. Anything else while we're here?
You talk about sawing.
Yeah.
I've been passing over 20 years and I don't want to touch a 6,000 or 7,000 thick blade.
You don't
I
what?
want at least a 12,000 thick blade, especially on my machine. And the difference in the slot that it cuts is just 2 or 3 thousandths to the side difference from the 6,000 or 7,000 thick blade, and that 12,000 blade go 10 times longer without wrinkling than the thinner blade.
Yeah.
Especially for new fasteners. That's a mistake a lot of new
Well,
fasteners.
I was talking about the use on the lap arbor, using it on the lap arbor and cutting
I
in
do
this
too.
way. Yeah.
Do too. But still, it wants to lead off.
Yeah, they sell them for 12 and 14 thousandths of nice. It's just that if you've just paid an awful lot for emerald, it's sad enough to watch it make this milky fluid go down the drain.
If it's
At least you get some little pieces.
Enough, it ain't gonna say anything anyway. Right?
Yeah. Yeah, I know. You know why? You know why I'm stressing thin? I'll tell you why. Because when you say, buy a saw, you know what people are doing? They're going over to Walmart and they're buying this tile saw. Okay, and well, I don't know. It's 60-80 grit, and it's something for a guy that's cutting tiles, and and it's a fixed speed, and it's just scary, and it's not made. It's you know what I mean. It's not exactly a slitting saw. And I'm trying to think, you know, I basically threw my notes away when I saw it in a small group. But with that, you know, I think I'll, huh? Go ahead.
Just one last question, go ahead.
Is there a right and a wrong time for aluminum oxide versus cerium oxide?
Aluminum versus cerium. What's that? Yeah, I should turn this off there. Yeah. Cerium oxide shows specificity for the quartzes. Aluminum oxide, I've known people who've said they've used it on quartz. They'll work on quartz some of the time, some quartzes some of the time. But cerium oxide and chrome oxide both were peculiarly suited to quartz. And it may be due to chemistry, among other things. It may be due to chelation. There's a lot going on in that. But they're not interchangeable. You know, it's a good thing you brought up. I'd say that the chrome oxide, now that we can get people to finally use it, is about halfway in between cerium oxide and aluminum oxide for accepting different minerals, for polishing different minerals. The only difference is that aluminum oxide is about the only one that will polish sapphire. Now, we've had reports years ago, maybe 10 years ago, 15 years ago, that somebody was using colloidal silica to polish sapphire. Well, it's intuitively it's not intuitively obvious that it would work. There are reasons why it might, but it has to do with solvation and other things going on. And it was an oddball. That was an odd moment in faceting. And you know, that stuff has stopped anyway, because the doctors online were all screaming about it.
But now, you work with developing labs.
Mhm.
Okay, if cerium will work for quartz and aluminum works for sapphire, and the old story, if it's not broke, don't fix it,
Right.
what is your goal with new lab materials?
Okay. I wanted to use, in the development of all my labs, okay, I didn't want this to be an infomercial because I was going to talk about it, but since we're over time, I will. I am just like everybody else. When I started fasting, I used Lexan, you know, and tempered hardboard, and Bakelite, and phenolic, and lead, and tin lead, just like we all did. The first thing that happened is our betters in the environmental regulatory industry decided that lead is no longer welcome. And further, that 100 pounds of lead scrap is a reportable toxic waste. This immediately brought an end to the lead alloy labs, because no manufacturer was going to handle that. You know, they also were going to risk a $10,000 a day DEUE fine if the stuff got in the river, and that is casting dross or things like that. So that was when I started on the lead-free alloys. Then I decided that I wanted a certain structure. And then I read a book by James Gleick called Chaos that basically changed my life. It changed my life professionally and what I did for a living. And it changed the way I looked at a lot of different things, especially what a lap should be, you know, and the different things that a lap should have. It should have a low frictional coefficient. It should have a chemical attraction to what its medium is. That is, water for oxides and oil loves diamond. So it should be long wearing, it should be durable, it should remain flat, it should retain its geometry. But the most important one that I began to realize was looking at all the things that had worked and hadn't worked over the years. For me, I'm a hobbyist. was that materials with a higher fractal dimension, a higher surface complexity, generally polish better than materials with low fractal dimensions. Now, I'm going to get in, I'll just give you a quick story about that. In 1967, Benoit Mandelbrot published a paper in Science magazine called How Long is the Coastline of Britain? And it gave you an interesting way of looking at complexity. If somebody took a map and they made a ruler, put a ruler, they measure it, and they say, oh, it's 10,000 miles. Now he said, well, I'm going to hire a surveyor, and the surveyor's going to go around, with this 100-foot tape, and he's going to go around, and he's going to measure, from Cornwall all the way around, and back down to Cornwall. He's going to write down the number. Now somebody else is going to say, well, I've got a better budget. I'm going to have this guy take a yardstick and do it that way. Well, when you start doing that, all of a sudden you realize, wait a minute, this isn't a perfect shape. It goes in and out, there's little bays and things, so this number comes out a lot bigger. Now somebody else says, well, I'm going to use a 1-foot ruler. Well, now there's rocks and there's water between where rocks and water meet, and now it becomes really complicated and a pretty big number. There's somebody else says, well, I'm going to measure it in inches. Now they're going between the grains of sand, the water and the pebbles, and all the pebble beach at Brighton and everything. And the number becomes a mind-boggling number. So there's a way of looking at complexity. In other words, how complex is a surface, and you can assign a numerical value to it. This allows you to analyze what's out there for laps, who's been using what. And there are a number of different ways of doing it. Most of them are tedious. There is a nice computer program that does it, though. And what it basically does is if I get feedback from customers, like most of you know that when I come out with something new, I'll send it to some volunteer testers. The volunteer testers are usually commercial and production cutters because they cut more stones in a month than most of us do in a couple of years, including me. So I don't want my impressions. I want to see what somebody who really counts on the thing does. So that's just another way of looking at some of the reasons why you would design a product a certain way. And what I did is, I've got a kind of a thing on my webpage that says what I used to do for a living. I used to make new stuff. And finally, my employer finally felt that I was reasonably good at it. And by that time, I got sick of the whole thing and walked away and pulled a Jean Galt. So here I am with nothing to do. What do you think I'm going to do? I'm going to use my technology base. I'm going to have fun for a change. That's what it was about.